Okay, so you just saw the little bit of work for the Minecraft. Let me just show you just a little bit more really quick. Your goal is going to be let's see, I can't minimize that just yet. So from here, if you look at it, I've graded an area, excavated an area. I put gravel, sand, dirt. You're going to put dirt, dirt, gravel, sand, and then I've poured concrete, and I've put a retaining block around it, a retaining wall. And now with a group, you're able to, it doesn't work quite as well as regular Minecraft. If I'm standing right here, you see in the upper left-hand corner, it gives me my coordinates so an inspector can come in and see if I've actually built this properly. The inspector is basically a surveyor. We're going to survey by GPS. I'm going to give you a map that you can excavate and do this work on. And you can go through the process. Then I'm going to give you an architectural plan that you can build on this site with. It's not always as easy to lay a place out as you think. You're going to have to do good marking and looking at your positions. Working as a team is easier because you can see if somebody's in place or not. You can record your notes. So this is essentially collaborative site work, and we can simulate really what happens on a site pretty well. Okay, so so there we go. That's what the Minecraft's going to work like. I'm still working. Apparently, our accounts are not set up well, so I have to get the accounts right. Hopefully by next week, we'll all be in and able to start working on it. Okay, so I will give you a world. I will give you some coordinates. I will give you a map. And you go in and just start excavating and laying down bricks. And you can do it as a team. So this took me about 3 hours to excavate, to lay all the layers down. This is a 25 meter by 25 meter pad. So that's a lot of stuff. And it took me about 3 hours to do this. So if you're working as a team, probably do it in an hour. And then your inspections, that takes a little bit of time to learn how to do. And then your construction gets pretty interesting as I give you floor plans and things like that to build, or you can create your floor plan if you wish to do it. Now, this work is really just kind of like playing around, getting good at it, so that when it comes time to do your research module, we're on module 2, your research starts on module 6, you can choose to do this simulation, or you can choose to research a building material or process. Okay, so that's what that's going to be. So there we go. I'll escape out of that. Escape. Save and exit. Save and exit. And exit. And exit. And okay. There we go. So this is an example right here of what I'll give you. I'll give you a visual, and I'll give you a topo map, and I'll give you a set of coordinates that you can see right here. So that's how we're going to do the Minecraft stuff. But let me turn a bunch of this stuff off. I was DT350ing. And so now it's time to DT300. Okay, so we're going to talk about the concrete compression test now. I was supposed to do something. Hold on, I'm looking at my notes. I'm supposed to do a little bit of work. I'm supposed to be doing a little bit of work on your portfolio template. So let me do that really quickly to show you some work. So first of all, here's my demo template. I want to make sure that you know how to share it. Share. This one says restricted. So this is a demo template. So I want you guys to be able to see it. So I'm going to click it and change it so that anyone with the link can view. And then when I go to get the link, that's what I want to share. Okay? So now let me see if I've got one. Do I have one with images on it? No, let me go find an image really quick. A quick way is to go to this explore button down here. And just type in up here, I'm going to do site demolition, and I'm going to look at images, and I'm going to pick this one. That looks good. And I'll click the add button. Now, what's nice about using these is these already have the links on them and everything if you use this. So you don't have to worry about all that linking and finding everything you want it eventually, but okay, so now I'm going to put it over here and I'm going to look at some ways I can work with it. First of all, if I squeeze it all down this way, oh my God, it doesn't look good. It's got a problem. I've got it in there a few times. Okay. When I squeeze it sideways to make it fit, it makes it look funny. Okay. So I don't want to squeeze from the sides. Even when I'm doing my drawings and all that stuff, I never do that if I can help it. I always squeeze from the corners. It keeps my aspect ratio. So now it fits. Now I might want to put it up here and put some more in. But look, I got sharp corners and round corners. So there's a few things I can do. I can go to my crop and I can crop the shape to have rounded corners. And I can click on the button and I can make it more round or less round. So that's kind of a cool thing. And I can move it till it's really on center. And if I think I got too much stuff on the outside, I can crop it right to an edge. And now I can resize this so that it goes right to an edge if I want. Now, personally, I like to leave just a little gap. I think it looks better if I can see a little gap, but that's not necessarily so. So that's how you play around with the images. It's up to you how you want to do them. I saw a few people make these square, and it looked pretty cool. And they brought it down so it's kind of in the middle. Or that there were two of them, and one hit this corner right up there, and another hit the corner. I think I can move this so it hits the middle. Maybe not. There it is. That's smack in the middle. Okay? So that's some work that you guys can do with the with the images. As I said, I like it to look at it more consistent and to have just a little bit of room around it as I look. It doesn't have to fill the whole area, but you might put 2 or 3 of them in. Okay? But always, always, always resize from the corners so the aspect ratio, that's the width to the height, stays the same. Stretching it sideways, it distorts it, and it's no longer a true picture. And when you're doing that with your, especially with your other images, it gets to be a problem. Okay? So there's a little bit of information on that. So here's our new study material, and hopefully you've looked this over a little bit. As you know, we're not able to run this test. You're supposed to have read this already and have looked it over. Has anybody got some annotations of this done already? Okay, that's going to make this lecture really, really hard. It's going to be very difficult for you to understand part of what's going on here. Okay. Hold on a sec. Okay, so Abdul, do you see where you, no wonder I'm in the wrong one. You guys should have reminded me to move. Okay, there we go. Now you should be able to be on it, and it's being recorded.
Yes, yes.
Okay. All right. Okay, so this is going to make it hard because here's your standard, and this is not an easy standard to figure out. So the idea was that you would read this and take some notes. So somebody tell me, what does this standard do? What does it tell you to do? What is it about? Well, it sort of says the scope. That's why you read the scope. Determination of compressive strength of a cylindrical concrete specimen. Okay. So, anybody know what that means? So, right off the bat, read the scope and it tells you what it's about. Okay, so compressive strength. Somebody tell me a little bit. We talked about it just very briefly. What is compressive strength? I'm going to start a Jamboard here.
Pastor?
Yeah.
Do you intend to share your screen in Discord?
Oh, it moved when I did that, huh? There we go. Thank you. Okay, so let's say I've got a cylinder. Let me draw a cylinder. So there's my cylinder. What is a compressive force on that cylinder? Which way do I push? Sitting on a table here. Which way do I push for a compressive force? Come on, you guys. This is we actually went over this last week. I'm expecting you to be active learners. Pushing down, thank you. So I'm gonna push down. Now that happens to be how concrete is usually loaded. And we usually look at the compressive strength of concrete to tell whether it's okay or not. So if I pour concrete, how am I going to know whether that concrete is any good or not? I'm going to take a sample of that concrete that I poured and I'm going to test it. Okay? And I push down with a force, right? And I'm going to measure those force in pounds. Well, if I test this on something that's like small, let's say that has a diameter of 2 inches. And I can take 1,000 pounds per square inch. Well, first of all, how many square inches am I pushing on? That's right. Samples have to pass the test. Okay, so if this is a 2-inch diameter, how many square inches am I pushing on? Pi d squared over 4. 3.141 times 2 times 2 divided by 4. 3 square inches. So if I'm pushing down with 3,000 pounds, how many pounds per square inch? £1,000 per square inch. And length times width, except I'm round. So pretty close. So if that concrete can handle 1,000 pounds per square inch, it'll just sit there and it's fine. If it can't handle 1,000 pounds per square inch, it'll bust. Let's say it will handle 1,000 pounds per square inch. And for concrete, that's very low. How do I know what my building will hold? what if my building is 100 square inches of concrete that I'm pushing down? It's got a great big column. It's 100 square inches. It's not all that big, right? 10 inch by 10 inch square column. How many pounds could that column hold? 100 square inches times 1,000 pounds per square inch. That's a lot. It can hold 100,000 pounds. So that's pretty cool. That's why we do these tests. If this concrete will hold in this small part, I can figure out if it will hold on my big part. And the engineer will come in and go, oh yeah, that's okay. I'm only loading it with something. So that's why we do concrete compressive tests. Now, the numbers are not always as easy to figure out in your head. Okay, yeah, so Shivani, I think, is doing civil engineering, right? This is like right up the alley. This is where you get it. So now what we really do is, instead of going, oh yeah, 1,000 pounds, that's cool, we test it till it breaks. And that's called the failure stress, failure load. Okay, and then engineers can know, okay, that's the failure load, and we've done so much work on concrete that we know how to apply what's called a safety factor if it's got this kind of rebar or this kind of strengthener or this kind of load or this kind of temperature or this, that. We know that from the failure load, we can calculate the failure stress so that we can calculate our building. Okay, so that's what a concrete compression stress is. You get a chunk of concrete and you compress it till it breaks. And this whole standard that you see here is how to do it in a very specific way so that we can all relate to the results. You do it at a certain speed and a certain area and at a certain time of the cure and with a certain fixture on the top to take care of irregularities and certain type of test specimen and a certain number of specimens. So, and then we look at how it broke, because how it broke tells us about how we expect the load to be used in the field. And if we think there's going to be shear, then it's worse for us if it only goes in shear than if it's column. So there's all this stuff that engineers need, but we need to know to do it right. And you might be required to be the person to take the concrete samples. That's what a technician does. A design technician does this type of work and knows all about it. Okay? Engineers have to take care to know that this was done in a very specific way, so they only apply it. to the things that they've been working on. Okay, and then the engineers have to even see if they're applying the loads correctly. Okay, so that's about how we do it. Now, let's take a look at the next thing. Oops, let's see. Now, I've got a sample. There's my sample, and I test it, and I get a number that says it's okay. This one is okay. I'll make it green. Okay, so I've tested it, and its failure stress is above my engineer's limit. So he says I have to have 4,000 psi. And this one's above 4,000 psi. Woo! I can just go to town, right? No. What else do I need to do? Anybody know what else? Can I just let the building go ahead now? Somebody tell me what else I might need to do. No, what do I need to do? Find the max. The max of what? You're on the right track. What do I have to find the max of? I need to find the maximum. Well, I need to find the maximum. I do want to find the maximum. So let's say it came out to be 4,400. It crashed. 4,000. You guys have watched my video, right? So it's okay. It's cool. You guys watched the video? I'm cranking it down. You can see it starting. It's just starting. You can see it right in there. Just starting. So that's fourth. Oh, there it went. Right at 4,000 pounds. And boy, I tell you, that went in a jiffy. Okay. So what we want to do now, what if I took that in a spot where they took extra care, but then later on in the day, they got some dirt in it, and it was a little bit hotter, and it was the fourth pour of the day. What else would we need to do? We'd want to take that sample, and 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 find out good, good, good. Uh-oh, got a lousy one. They were all good, except for those two. So then we have to start looking at the data and doing statistics. Okay? So now this is not a class about statistics, so I gave you a spreadsheet with all the statistics in it. But you probably should understand the basics of statistics. And we're going to talk about those very, very briefly. If you don't know those, I can suggest some classes, but there's a program called Purple Math that's phenomenal. And you just type average Purple Math, and it is such a good explanation. Um, and so you can look at those things if you want. I actually, when I tutor people, I tutor some people at other colleges in the basic statistics and things that we need for this. I use Purple Math. It's phenomenal. Okay, so we need a whole bunch, and we need to know about the data, and we need to know, were these two really horrible? Were they like at 1,000? Or were they at 3,900? And stuff like, we need to know that. And were most of these up at like 5,000 or 4,050? Was it a really, pretty tight range? And then the engineer will look at this and go, oh, okay. No, if those were that far down, I got a serious problem. I got a quality control issue. Here, I can look at it. So you take many, and you look at something called the distribution. And if they're all over the place, the engineer's going to be going, oh, I think I got a little quality control issue. They should not vary by that much. Okay? And if the distribution looks good, then you can look and say, well, I added some safety factor in here, and I can look at it and be okay. So that's a whole bunch of those. Now, how long does it take, again, to reach a good, steady part of the cure? Kind of on a minimum. Do you guys remember that from the other class? So maybe they took this at 7 days. Okay? And the engineer knows that he's got a little wiggle room because he's really looking for about 6,000 to 8,000 psi, but at 7 days, he wants that. He's got a couple of them that are like this. So what's the next thing they're going to do? Yeah, curing at least 1 week, Adrian says. So now they're going to do the test at 10 days. And they're going to do the same thing. Not on those samples, of course. And by now, they want 4,500 psi. And they're getting in the 5,000 range. Except for this one that they got at 4,300. So again, it's going to be up to the engineer. This is why it's tough to be an engineer, man. They have a license. They are responsible for safety of the job. It's all up to them, which is why, let's say he's going, I just don't know. This test has to be done right. they have to rely. You cannot be faking this data or doing things wrong. Now, what happened on the Bay Bridge? Anybody know what happened on the Bay Bridge? So Caltrans has a huge group that does this type of testing and quality control. Now, I happen to know this because one of the guys I graduated with has been working for Caltrans for the last 30 years, and he's part of that group, quality control group. And on the Bay Bridge, they had a whole system, and everything was set up, and everything was cool, and they were going to make the cool new Bay Bridge. And the governor, this is one of the ones that Schwarzenegger really messed up. He did a lot of good things, but he really messed this one up. He said, no, that bridge doesn't strike my fancy. It's not cool. It doesn't bring people to San Francisco. We want a new design. We want you to fast track it. You're going to outsource this, and they outsourced the quality control to other groups. And all of the footings are below spec. The stuff was actually not tested according to Caltrans standards. They were tested to a different standard, and they will not handle a level 8 earthquake. They'll do a 7.5, but they won't do an 8. And the spec for that bridge is an 8. And how about the bolts? You guys know about the bolts? Guy falsified the data. False data. We have to rely on good data. If you get into these situations, and I'm sure that's probably why that building, yeah, it's like, it's crazy. And so I'm sure that's why that building I worked on pancaked. Okay, so here's what happens. When you really do this stuff, somebody specs the concrete. Okay, they go, it's got this much sand, this much aggregate, this much coarse, this much cement, this water mix, it's got this additive, and they spec that. That gets mixed up by Tykert or whoever it is that's mixing the concrete. And somebody signs off that mix because they did what's called a sieve analysis. They actually put it in these great big screens, shake, 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 shake. They measure it. They know exactly what went in that truck. And a responsible engineer or technician signs it, and the truck driver has it. And they take it out to the job site, and the truck driver hands it to the foreman, and the foreman looks at it and says, okay, we'll use your truckload. Put in the water, and they put in exactly the amount of water that the site engineer has called for, and they mix it the exact amount of time, and then they do a slump test to see if it's working right. If it passes the slump test, they'll pour it, and at the same time, they'll pour 30 or 40 or 50 test coupons, and they will cure those test coupons in exactly the same way that concrete is being cured on site. And then on the day of the test, they'll take it to a lab that's been certified, and they'll put it on the machine, and they'll break it, and they'll get the data. And they'll report that to the engineer. And if there's a problem, they'll put a hold on any other work or not. Now, depending on the work that's being done, you can do some work. You can do tilt up, you can do framing, you can do plumbing, you can do survey, you can do measurements. There's a lot of work. But if it's a concrete structure, you can't do certain part of the work. Okay? So that's sort of how the system works. So let's take a look and see what some of the data might look like. Here's data. Now this was done in class on those test coupons, so you don't have to worry about it. But let me take a snip of this and put it on the Jamboard. So you can kind of see that. But you'll notice down here, there's some tests that failed. So this test, this group right here was just piece by 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 piece. They were just pulling pieces. Okay. Over here, this set is put into order of failure stress. So you can see some of these met the failure stress and some of them did not. So let me take a little snip of that just so that you guys can see that. There we go. That's pretty close. Now, that's not all the data, but it gives you the idea. Okay, so here, there's data. There's the size of the part. These were square. And this is how many pounds it failed at. 5,400. And here's one that failed at 5,020 and 4,660. 4,200. Here's one that failed really low. 3,650. Now these were, just because I know, taken from concrete stepping stones. So there might have been some mix up of parts and this and that and the other thing. But this is the area that was being pressed on. Remember we did that calculation? So this was the measurement. This was the load when it broke. And so this was the area, and that stress is how many pounds when it broke divided by the area we were pushing on. So that's the failure stress, and that's what the engineer needs to know. Okay, and you can see it was kind of all over the place. But this is just data. We don't know if this data is good or bad because we don't know what the engineer needs. We don't know that information yet. So here I did some data analysis. So let me calculate back out. Now I took all of this data and I put it in order from the highest to the lowest. And I did those calculations. And then I looked at what the engineer said that I needed. Okay. Oh, and the engineer, I think, told me that I needed 1450. Okay. But I'm going to look first to see, is this a good test? Remember I said that if the numbers were all over the place and there was too big of a spread, it would indicate that there was poor quality control. So here my engineer is telling me, I want certain things to be green and certain things to be red. When I look at this data you give me, before I look at it, I'm going to let you know whether I have a good test or not. Okay, and so this is how the engineer determined a good test. Wish I could do a window. Anybody know? These are all ways of saying average. These are all ways, right here, ways of saying average. Who can tell me what the mode signifies? It's a type of number. When I look at all these numbers and group them together, most often, thank you. So out of all these numbers, this number came up the most, 1,563. Okay, so if I look at all the data, that exact number shows up the most. Okay, what does median mean? Median. The middle number. Yep, it's the middle number. So if I look at all of the data and I took an even number of data points above and an even number, so if there were like 20 of these, I'd see 10 data points above and 10 data points below. And look, these happen to be pretty close to each other. Engineers like that. It means they're sort of like things are well grouped. Okay, when the mode is pretty close to the median, engineers like that. They go, I got good data that seems to be the same all the time. And then there's something called the mean. Okay, and Eric says that one's the average. Yeah, it's what we normally call the average. These are all averages. This is the mean says add these all up and divide by how many there are. That's the mean. Now the standard deviation is just a number. It's a number that got made up. Okay, it's a made up number. But it's a number like stress that is kind of important. It says how spread apart is your data? Okay, so like, is it all kind of packed together tight? Or is it not? So you can imagine that if these numbers, okay, were all about small numbers, these would be, but if there were millions and millions of data points and they were all packed together really close, it would be pretty cool. So this is just a number that tells me how packed together are things. Okay? And if all of these points are within one standard deviation, engineers kind of like the work. They go, okay, I'll go with it. Whatever number I choose, I'll go with it. That's cool. That's how engineers work. So these are four really, really important numbers. They're just calculations. You don't even have to know how to do them. You use your spreadsheet. You just type in equals mode and do your numbers, and it pops out. And equals median, and it pops out. And equals mean or equals average, and it pops out. It's like you don't even really have to know. Yes, so Kate is right. How much do the numbers vary? So to actually find it, it's called sum of the root mean square is what the number was when I was taking it. You take this mean number and subtract it from this number and record it. And then you take the square root of that, or then you square that, and then you add them all up, and then you take the square root of that. Oh my God. So blah, blah, blah. It's a measure of how much each one of these is different from this. And so you can imagine if each one of these was pretty close, your standard deviation would be small. But what engineers really like to do is see if all three of those are within that. And if they are, they're going to go, okay, I like my data. Go to town with it. And then they're going to list the max and the min and apply some sort of calculation. So it takes the average and rounds it down to the nearest 100. So it's going to take the minimum of the averages. These are the averages, mode, median, and mean. It's going to take the minimum of those, 1563, and round it down to the nearest 100. That's what the engineer says. Report that number to me. And I'll compare that number to what I require, and you can tell me if this batch is good enough or not. So it's pretty complex, but it's not, it sort of makes sense when you really think about it. A whole mess of random data, taken a whole bunch of times on site right during the pour. Organize them so that you can see them from the biggest down to the smallest. Do a little bit of statistics that Excel already knows how to do, but that means something. They're ways of telling you if your data seems reasonable. And if you compare your data points and it seems reasonable, you say yes. If you say yes, you need to look at these and say, okay, this batch gives me a number. The batch gives me a number. And now I can use that one single number to determine if it's okay or not. That was some work. So what are you going to do now? Well, first of all, I've made it just a little bit different. Just a tiny bit different. Okay. But you're going to show you're going to answer questions about your concrete compression test here. What does it test? Let's see. Compressive strength of cylindrical concrete test specimens. It's right there. Or you can go by what we've said here. Well, here, it's easier to see over here. When is it done? We've just talked about that. Where is it done? We've just talked about that. How is it done? That's certainly in the standard. Who decides if it passes or fails? We just talked about that. What could happen if construction continues after a failed test? We talked about that on last week. Present a graph of your test results along with a summary of what it means. So that would be down here. This would be your graph of your test results. And you would say what that means right in here. From the graph below, you can see that. Yeah, watch more videos. Okay? And I'm going to show you something about that too. I know I'm going just a little bit over. And then I've got the hard one. Compare this test report. You're given a test report here. I want you to look at this test report and compare it to what it says to do in this standard. So those of you who are in that standards reading class, this should be right up your alley. Test report. Test report. I wonder if control work F in. Test. Test report. Talks about it. There it is. Test report. Well, there's a little bit about it. There's more about it in here. So you can read this through and look and see what you're supposed to report. Okay? And who you're supposed to do. And what the apparatus is like. And the specimens. And the calculation. Okay. Oh, here it is. Here's the report right here. Identification number, diameter, length, precision and bias. So you can look at this and compare it to this and see if this falls a little bit short or not. Okay? So I want to show you one more quick thing, and then I've got a meeting to go attend. I put in here collaborative video key point spreadsheet. And we're going to be making a wiki of this, but as you guys watch these videos, help each other out, please. Give each other a hand. When you watch a video, okay, go to this form and give your sense. What date do you find it? What was the title? What was it talking about? And then keywords. It was about the standard. It was about, but try to do a good job on this of really getting some keywords and important notes. Okay, let people know what was important about that one particular part of the video. And when was it? This was from, 12 minutes and 15 seconds to 16 minutes and 32 seconds. Watch that little part and you'll get these important notes. Okay? So this one here is for anything in Design 300. We're putting together a wiki page that will pull them together for all of them. I will have one of these made up for 301, 350, and 498 also. Okay, so that was Kate's question. So you've got now a spot that you can go, and then you can always go to this spreadsheet and look things up. Control F. Maybe I'm looking for performance. Oh, there's one about performance. Maybe I'm looking for concrete. Nobody's putting anything in about concrete yet. Maybe 2.2.1. I need to know something about 2.2.1. Okay, as this gets bigger, you can use this Control F to find things in here, and eventually it'll become a wiki. Okay, which is an easier way to look at things. Okay, so there we go. I'm going to turn off the recording.